Hey everyone, so today we are talking about a new type of naming, and fortunately this is actually pretty easy. So before we were talking about ionic bonding, which was metal and a non-metal. This is things like sodium chloride, iron 2 carbonate, silver nitrate. Okay, these are things that involved something on the left side of the periodic table mixed with something on the right side. Well, now we're talking about covalent bonding. Covalent bonding are non-metal bonds. So we're talking two things on the right side of the periodic table, or hydrogen mixed with something on the right side of the periodic table. So with ionic bonding, we didn't have to state how many of each atom there are, right? We didn't say di-iron tricarbonate because the charges help determine that. If you have sodium chloride, sodium has a +1 charge, chlorine has a -1 charge. You know that they're just going to bond in a 1-to-1 ratio. If you got calcium chloride, you know calcium has a 2+ charge, chlorine has a -1 charge. Those are going to bond in a 1-to-2 ratio. But the thing with covalent bonding is that they don't bond based on charges. They bond based on sharing electrons. So you could have multiple of either one. You could have H2, you could have CH4, you could have CH6, okay? It all just depends on how many they're willing to share. So we have to state how many of each atom there are, and that's why we use these prefixes here. So mono just means 1, di means 2, tri is 3, tetra is 4, right, from tetris, 5 is penta, 6 is hexa, 7 hept, 8 oct, 9 non, and dec 10. Alright, so when we are getting two nonmetals here, you will have to use these prefixes to state how many there are. You see this with carbon monoxide, carbon dioxide, okay, carbon tetrahydride, things of that nature. So let's do a couple examples. I'll keep the prefixes up right here. And say we are dealing with P. Let's get a marker that works, huh? Say we're starting with P2Cl5. So first thing you would do is you would look at this compound and you would say, is this ionic or covalent, right? Because we're not just going to have just covalent, we're going to have covalent and ionic. So I'll look at this, I say, is this ionic or covalent? I look at my periodic table, it's got phosphorus and chlorine, those are two nonmetals, so I know that this is covalent. Alright, I'm just going to put a little C over here just to remind me that it's covalent. So what I have to do is I have to use prefixes to state how many of each atom there are. Since there are two phosphoruses, I'm going to say diphosphorus, which sounds like I hate phosphorus, right? Diphosphorus. Anyway, diphosphorus, and then chlorine, right? That's going to become chloride. We still do that. But instead of just chloride, it's going to be pentachloride because I have 5 chlorides. I have a pent there, so it's going to be pentachloride. I don't want to say just pentachloride. That's too hard. That's two consonants bouncing into each other. So I put a little vowel in there to kind of break it up. Pentachloride, right? Diphosphorus. I got a little vowel there to help me out. It's not diaphosphorus. It's just diphosphorus. Okay. Let's look at another one. Let's look at B3O7. So once again, I ask myself, is this ionic or covalent? I look on my periodic table. Boron's a nonmetal, oxygen's a nonmetal, so we're going to be using prefixes here. Okay? So I got to state how many borons there are. There's 3, so I'm going to use the prefix tri. Triboron. And then 7 oxygens. Remember, oxygen becomes oxide, but I'm not just going to put oxide. I'm going to put heptoxide. Heptoxide. That sounds good. Heptoxide. Those are two vowels next to each other. I don't want that. I want heptoxide. That sounds nice. Triboron, heptoxide. There is just one weird thing about covalent bonding. And you will see that whenever we have a nonmetal that is by itself at the beginning. So let's go ahead and put SO3. Okay? SO3. You might want to say, okay, this is covalent, nonmetal, nonmetal, so I want to say monosulfur trioxide. Here's the thing. If the first atom is by itself like sulfur is, there is no need to put mono. You could just put sulfur trioxide, okay? The mono is redundant. The most common real-world example that you hear of this is carbon monoxide, right? We don't say monocarbon monoxide, we just say carbon monoxide. So whenever you see a S by itself, it is going to be, and it's the first atom, you just say its name, all right? But, like I just said with carbon monoxide, right? The first atom is by itself, so we're just going to say carbon, not monocarbon. But if the second atom is by itself, we do have to state that it's by itself, that it is mono, okay? Carbon monoxide, right? CO2, we don't say monocarbon dioxide, we say carbon dioxide. So just be aware of that. If the first atom is by itself, no need to say mono. If the second atom is by itself, you do have to say mono. One more thing that I just think is fun. H2O. If you look at H2O, right, it's got hydrogen, which remember is one of our nonmetals. It's just the loner that stays away from the rest of the nonmetals. And oxygen is a nonmetal. So how could we name water in a covalent way? Well, they're both nonmetals. How many hydrogens do I have? 2. So this is just going to be dihydrogen. O is, since it's by itself and it's the second atom, I do have to put monoxide. Dihydrogen monoxide. You will see every now and then in the news, somebody in the paper will say there's a dangerous dihydrogen monoxide in our water system. They're just messing with people, trying to make them scared, because dihydrogen monoxide does kind of sound dangerous, but really it's just water. So now you hopefully will never get fooled by somebody who tries to scare you by calling it dihydrogen monoxide. You also have some nerds out there call it dihydrogen monoxide, but we don't talk to them. Okay, one more. And then I'm done. Actually, okay, first thing I gotta do, ionic or covalent. I look at my periodic table, I see arsenic on the right side, I see fluorine on the right side. That's a non-metal bond. That has got to be covalent. Prefix time. I have 5 arsenics, so that'll be pentarsenic. Pentarsenic. 9 is nonafluoride. Okay, nonafluoride. Let's go ahead and work backwards a little bit. So let's go from name to compound when we're dealing with covalent bonds, okay? First thing you gotta do is you gotta look at the name and say, is this ionic, covalent, or an acid, which we'll deal with later. But I look at this, and I'm looking at nitrogen trioxide, and there's gonna be something that gives it right away that tells me it's covalent, and it's that tri, right? Whenever we see a prefix, we're gonna say, hey, we're dealing with a covalent bond here. So let's go ahead and name this guy. It should just be the formula based on what it tells us there is of each compound. Nitrogen, there's no di, tri, or tetra in front of that nitrogen, so it's just N. And then since it's trioxide, that tells us that there are 3 oxygens. NO3. The next one, I look at that, it says tetraphosphorus octachloride. It's got some prefixes in there. It's got to be covalent. Tetra, what does that mean? That means 4, right, from tetras. So P4, because tetraphosphorus. Octachloride. Octa means 8, right? Our octopuses have 8 tentacles. So it'll be Cl, but I will have 8 of them. I look at decaselenium heptiodide. I see some prefixes there. It's obviously covalent. No need to balance charges here because the name tells us how many there is of each ion. Decaselenium, that means 10. 10 seleniums. Heptiodide. Iodide is iodine, and hepta is 7. Hexa is 6, hepta 7. And then carbon tetrafluoride. Carbon, just C. Tetrafluoride is, oops, not 3. Tetrafluoride is 4 fluorides. So pretty easy to go from name to formula. Easy to identify. Once you see a prefix, you know you're just writing down however many they tell you. So I have some practice below. Make sure that you are checking to see if the compound is ionic or covalent, because I'm going to throw some ionics in there. So give that a shot, name accordingly, and have yourselves a great day.